Okay, let's begin by thinking about the parent function. This one looks a little bit complicated, x minus 2 inside these absolute value lines. These are absolute value lines that I'm highlighting in red. Minus 3 take away, or is less than 1. Let's graph the parent function. The parent function looks like this. It says y is equal to the absolute value of x. And, if x is equal to 1, then guess what? Y is 1 too. I guess we could say if x is equal to 0, y is 0. And if x is equal to 2, then y is equal to 2. And if x is equal to 3, y is equal to 3. And so forth and so on. We can see that this goes up at a nice straight line forever, as far as we can tell. I tried to make it straight. But the interesting part is when x is negative 1. Well, when x is negative 1, the absolute value lines, those lines on the outside of 1 of x, say to that negative 1, you can't be negative, you have to be positive. So when x is negative 1, y turns out to be positive 1. You might have expected that it would be negative 1 and keep going down in the same line with what we started with, but no, it's positive. The absolute value has to be positive. So then when x is negative 2, y is positive 2. When x is negative 3, y is positive 3. The absolute value won't let it be negative. So we end up with this V-shaped graph. If I could have kept that straight, I would have liked that better, but no matter. And the interesting thing is that this absolute value is said to be less than. I made it equal, but we're talking about less than. So I want to draw a line that represents that level, and we're thinking about this 1 right here. So I'm going to draw the best I can a straight line at 1. Oops, didn't need to make those marks. I don't really like that. I'm going to try that again. I'm going to draw at there we go. That's my best attempt there. Y is equal to 1, and there are going to be times when my v that I drew here in red, the parent function, there are going to be places where it's above that line and places where it's below that line. And so I'm thinking here, let's choose a different color, and we're going to say this thing moves over 2 places. Is it to the left or to the right? Well, negative would make us think it's to the left, but honestly it's to the right. So this means go over 2 places to the right, which to me seems like positive. I know it says negative, so to me that's opposite. And then the negative 3, it does indeed go down 3. So we're going to go from our 0, 0 point that we started with for our parent function, and we're going to go over 2 and down 3. So here's our new bottom of our V. Okay, and we could try to draw. We could kind of sketch this like this, and kind of hope that we hit the blue line in the right place. But instead of doing that, I'm not going to do it that way. I'm going to solve this inequality 2 ways. First, I'm going to solve it in what I call version 1. So I'd say version 1 looks like this. It's x minus 2 minus 3 is less than 1. And that looks like the same equation, or inequality. It's less than 1. The only difference is I left out the absolute value signs. And then I could say, let me also do version 2. When you have an absolute value, you're thinking there's 2 different versions, because there are positive values of x that will work, and there are also negative values of x that will work. So we will say x minus 2. That part doesn't change because that's inside the absolute value. But the negative 3 in our second version becomes positive 3, and our less than becomes greater than, and our 1 becomes negative 1. Everything outside of the absolute value changes to the opposite. Okay, so we're going to get 2 answers now for x. Let's go ahead and solve these. And we'll say, okay, so x minus 2 minus 3, that's going to be minus 5 is less than 1. And then we're going to add 5 to both sides because we need to move it over there. And we'll say x is less than 6. So I'm going to go over here to my blue line, and I'm going to put a dot at 6, okay? And I'm going to say I don't have to guess where that line goes. I'm going to draw it through 6, okay? I know where it crosses the blue line. And then with my orange color here, I'm going to solve this, and I have x minus 2 and plus 2, so I'm going to have x plus 1, the 3 wins by 1, is greater than negative 1. Then I'm going to subtract the 1 to move it over to the other side. And I'm going to have x is greater than negative 2. So the other point on my blue line at 1 here is negative 2. There's my other point. And I'm going to draw my line the best I can straight through there. And okay, so that's my parent function, my red absolute value function, moved down 3 places and over to the right 2 places, and I know exactly where it hits. So we said that it was going to be less than 1 when x is less than 6, and you can see when x is less than 6, it is indeed less than 1. It's under the blue line. And you can also see that when x is greater than negative 2, when it's greater, that means less negative and greater, you can see that it is less than this blue line. This area right here is all less than 1. So in that area between negative 2 and 6, it's less than that blue line at y equals 1. Everywhere else it's greater. See, it's greater than the blue line. And over here it's greater than the blue line. Just in that section between those 2 values. And that's the idea. So it needs to make sense, and it needs to show how we shifted it over and shifted it down.